right, well, welcome back. We are going to talk about how to find derivatives of exponentials. We talked about in my last tutorial how we got the derivative of e to the x and the derivative of a to the x. So we're going to go through two examples. These are a little bit tougher examples. Uh, Most of the easier examples I know you probably do in class. So I'm going to go through some what I think are tougher ones that maybe students are a little bit confused about. So without further ado, we have example number one. We're going to do example number one just so you're not confused at what we're doing. We're going to find the derivative of e to the x squared, e to the x squared. Now, when you're doing this, we're going to be using chain rule because we have e to the x squared, e to the x squared. So really, we need to relook at this and saying, all right, u is going to equal x squared, all right, because that's going to be our value. So we're going to change this to d e to the u du. All right. And I'm writing this out. Normally I wouldn't do this. However, I'm just going to try to use a chain rule. This might be a method that you've used in the past where you're going to replace u, the composite function, the one that's inside the other one, with u. All right, so we're going to take this derivative. And what we get when we take this derivative is we're going to take the derivative of e to the u, which is going to be, well, we know is e to the u, okay, with respect to u. Now we need to take the derivative of u with respect to x, all right, with respect to x, all right, because in this problem right here, oops, I wrote it wrong, all right, is that we want to take the derivative of this with respect to x, all right, and so we want to have that, so not u, so the derivative of that would be, well, the derivative of e to the u with the u is u, and the derivative of now u with respect to x is going to be du dx, so what do we have here? Well, first off, we have the derivative of u, all right, with respect to x, then is going to be 2x. So u prime is going to equal 2x. So we can just write this as e to the u times 2x, which we have to get rid of the u, so it'd be e to the x squared times 2x, and that would be our derivative. Pretty easy? Yeah, sure. All right, besides a little mistake I had in the beginning, but on that, yeah, it's using the chain rule. All right. Well, let's try another one. All right, we're going to use another chain rule problem. All right, this one over here, example number 2. We have 5 to the tangent of x. All right, 5 to the tangent of x. This is an example of where we have a to the u. So if you recall, all right, I'm just going to write this out. Use green here. All right. D to the x, when we found a to the x, that equals a to the x natural log of a. All right. The a is a base, which is not e. Okay, so it's a base greater than 1 or greater than 0, but can't equal 1. All right. So what we have here is 5 to the tangent of x. So we want to figure that out. To do that, once again, we have 5, which is our a to the x, but we have, once again, tangent of x, which is not like u. So what we're going to, which is not x, so we're going to use, all right, chain rule. U in this case is going to be tangent of x. All right, so we're going to rewrite this out as 5 and see if I can do this correctly this time. All right, dx. And so when we have this, what we're going to have is, well, the derivative of 5u with respect to u is 5 to the u, here, 5 to the u, natural log of the base, all right, of the base. In this case, it's going to be equal 5. Times now the derivative of u with respect to x. That's the chain rule. Well, the derivative of tangent, we should know, is secant squared of x. All right, so the derivative of this right there, all right, derivative of u is secant squared of x. So we're going to plug that in there. So I'm going to just write this out, finish it up. 5 to the u, well, u is tangent of x, natural log of 5. And the derivative of u is secant squared of x. Right there, my friends, is our solution. All right, 2 different problems, both using chain rule. One using e to the x and one using a to the x. I hope this helps you out. It's a little bit tougher ones using a chain rule, but I hope hopefully this will help you with some maybe other